New module, section 5-1. We're going to step away from the graphing for the linear equations for just a little bit. We're going to talk about multiplying and dividing expressions with common bases. Let's review real quick exponential notation. Remember the definition of a base raised to a power of n. B is any real number, and n represents a positive integer. Then the base is written every how many times you have the exponent. So if you had, for example, down here, f, let's look at number 1, f to the 5th. That means I would multiply f 5 times. All right, and for number 2, remember this is going to be -3 multiplied twice. And for g, there is no exponent there. It's, as they say right back up here, it is an implied exponent of 1. So this is g to the first power. So g is the base, and 1 is the exponent. And the same here. These would be your base, and 2 is my exponent. Number 4, what is the exponent for the factor of 3 in the expression of 3c to the 8th? What is the exponent for 3? Well, do you see an exponent sitting here on it? No. It is the implied factor of 1, but you're not going to see them put that in the problem. You are to understand that it has an exponent of 1. And then for 5 through 7, we're going to write the expression using exponents. That would be m to the 4th. 1, 2, 3, 4 m's, but only 1 -3. And again, I don't have to put that exponent of 1. This has the expression 5a. So we want to keep that together in parentheses. How many times did they list that factor? 3 times. Now, it's not wrong to say this is 5 to the 3rd and 8 to the 3rd, yes, but since they kept the 5 and the a together, we want to do the same when we write our answer. On the top, rewrite. There's 1, 2, but 3 factors of x. On the bottom, I have two factors of the same binomial y plus 3. Evaluating expressions with exponents. For 8, 9, we want to evaluate 2 expressions and compare the answers. Now, I talked about this earlier. Remember, this has the parentheses in it. So this is actually going to represent -4 times -4, which is going to give you a positive 16. This one is not being squared. It's just hanging out. 4 is the only thing that is going to be squared. And so you end up with the value of 16 and -16. So they're not the same. Let's compare number 9. Anytime you have a fraction raised to a power, you can break it apart and use the top and the bottom to the same power. Now, what is 1? Talk about 1 for a second. What is 1 squared? 1 cubed, 1 to the 4th, 1 to the 100 or 1001 power. It's all going to be what? Remember, it's 1 time 1 time 1 time 1 time 1. Every how many times your exponent tells you to do that, it's still going to have a value of 1. So cannot I simplify this numerator and make it just be 1? And therefore, it matches the other expression. So these 2 expressions are, in fact, equal. And yes, you could go ahead and say 2 to the 3rd is 2 times 2, 4. 4 times 2 is 8. Yes, these both do equal 1/8. All right, for 10 through 12, they want us to evaluate the expressions. Number 10, anything to the first power. It just means there's one factor of itself, so it's still just 22. For number 11, we just discussed on the other slide that 1 to any power is going to just be 1. But now notice this has a -1. So the question is it going to be -1 or is it going to be +1? Somewhere earlier, we talked about negative. If you have an even exponent, then you're going to have an even amount of negatives. and it takes two negatives, remember, to make a positive. So this is in fact going to be a positive 1. And then finally on number 2, I will bring the negative down. It has nothing to do with 2 being cubed or 3 being cubed. And so this is going to be a negative. 2 times 2 is 4. 4 times 2 is 8. And then for 3 on the bottom, remember that's 3 times 3 times 3. That's 9 times 3 is 27. All right, for 13, they want us to simplify using the order of operation. So the first thing I have to do is the exponent. So I'll take care of this first. Negative 1 to the 5th power. That's an odd amount. So when I raise that, I will end up with a negative 1. Negative 2 times negative 1 is a positive 2. 14, I have to do the exponents first. That's 3 times 3 is 9. Plus 4 times 4 is 16. And 16 times 4 is 64. Then if you add 9 and 64, you do get 73. For 15, go to the exponents first. That's 2 times 2 times 2. That's 4 times 2 is 8 minus 4 times 9. That'll be 24 minus 36. All right, on 16, we're going to, through 19, we're going to evaluate using x equal negative 3 and y equal to 4. So I have negative 3, parentheses, I put negative 3 to the 3rd power. Now, yes, you may use your calculator on these, but I want you to understand kind of what's going on here. This negative 3 to the 3rd is negative 3 times negative 3 times negative 3. And so altogether you actually really have negative 3 to the 4th power. So you end up with a positive, that's 9 and 9, so you end up with a positive 81. Now number 17, I have a negative 5 and I'm going to substitute for y to be a 4. And so negative 5 times 4 is negative 20, and now you have negative 20 squared, so we know that's going to be a positive 400. All right, 18, we're going to substitute for x, a negative 3. Then we'll have a negative 3 times a positive 4 plus the value of y squared. So real simple, this is 9. This is going to be a positive 12 and a positive 16. These two combined make 21 plus 16, and I have 37. And lastly, I have negative 3 minus 4 cubed. So that makes a negative 7 cubed. So I know the answer is going to be negative because you will have 3 negatives. Remember, negative 7 times negative 7 times negative 7. And 7 to the 3rd is going to be 343. All right, now let's talk about multiplying and dividing expressions with common bases. So multiplication expression with like bases, if your bases are alike, but you have different exponents, then you can add those exponents. And if we're going to divide expressions with like bases, you can subtract them. Now, I often show students this. It's not a little trick, but it's a little something to help you keep it straight in your mind. You know the order of operations here. When you're dealing with like bases, for example, let's just say x to the 3rd times x to the 7th. You understand this means you have x multiplied 3 times, and this means you have x multiplied 7 times. 1, 2, 3, 4, 5, 6, 7. So altogether, how many x's do you have? Well, you have x to the 10th power. So essentially what you're doing is just adding these exponents. And how this little trick here with the order of operations, if you are dealing with like bases and they are being multiplied, you're going to step down and add the exponents. If you're dealing with like bases and they're being divided, you will step down and subtract. And I'll show you in a minute too, we're going to use this one as well. If like bases, if you have an exponent raised to an exponent, you'll step down and multiply. So let me just show you how the division works as well. I'm going to do the same little example here. Let's just do x to the 7th divided by x to the 3rd. Remember that's 3, 4, 5, 6, 7 on top, and that's 3 on bottom. Well, anything divided by itself makes 1. You can divide those out, and what you're left with are 4 x's on top, which is the same as me saying, look at here, 7 minus 3 is 4. Now, if you just subtract top minus bottom, or the numerator exponent minus the denominator exponent, and whatever you get, you have to put your absolute value of that has to go wherever the biggest exponent is. See, my leftovers are on top. Had this problem said x to the 3rd over x to the 7th, you would have had 3 on top and 1, 2, 3, 4, 5, 6, 7. See, these would have divided out, and you would have had 4 on the bottom. So if I subtracted 3 minus 7, the absolute value of that is 4, and that tells me I need to put that answer in the denominator. Let's look at some more examples on the next page. Okay, 20. We have like bases. They're being multiplied. So essentially all I have to do is just add these two exponents and get x to the 8th power. Same thing here. Like bases. So all you really have to do is add those exponents, and I get 3 to the 8th power. 22. Now, be careful with this one. Students tend to forget, let's blow that up. Students tend to forget that this is to the 1st power. So when you're adding them all up, remember this is a to the 3 plus 1 plus 5. So you actually have a to the 9th power. Don't forget that, understood 1. 23, we're going to write the answers in exponent form. All right, so this is 5. We're going to say 5 minus 3 gives me 2. My biggest exponent's in the numerator, so that's where my leftovers will be. So I'll have g squared, and of course you could put it over 1, but really you just need the answer of g squared. Here, there's an understood 1 on 24 as well. Don't forget about that. So you're actually saying 4 to the 3 minus 1, which gives you 4 squared. And finally, 25. Notice all of these are y. So I'm going to take care of the top first. We've done these with the fraction bar before. I want to take care of and get one term on the top, which means I will just need to add them. 3 plus 6 is 9 over y to the 4th. And then I will subtract. 9 minus 4 is 5. And my largest amount is in the numerator. So that's where I will put my remainder. Because if you think about it again, that means you're going to have 2, 3, 4. When you divide all these out, you have 5 still left in the top. That's why I say your remainder will be in the numerator. Now we're going to simplify expressions with exponents. It says use the commutative and associative properties of real numbers and the properties of exponents to simplify the expressions. What they kind of want you to do, sometimes they show you, is to maybe group like terms so that you can maybe more easily see them. It's not a necessary thing you have to do, but it does help in making sure you don't make common mistakes. So let's watch here. You're allowed, because everything is multiplied, multiplication is commutative, we are allowed to rearrange and just put these constants. Let me blow this up so we can see a little better. You're allowed to just put these constants side by side and then say, okay, let's put the C's, if I get the right pen going. Let's put the C, base of C together, and then let's put the base of D together. And of course, you know all these are multiplied. And then once you do that, you can just go through and multiply them. Negative 12, C to the what? 5th, because you're adding. And then D to the 4th. 27, we can do the same thing. Or you can go ahead and strictly multiply. Remember, it's constant times constant. And then all the matching bases can be multiplied together as well. So you end up with negative 12 r to the 8th power. 28, the first thing I see is that all the bases are the same. So what I'm going to do on top is add them all together, because you want to take care of the, remember that fraction bar here, we need to clear out the numerator and clear out the denominator before you take care of the fraction bar. So this is going to give me a to the 14th on top. Let's write that a little better. On the bottom, that's going to give me a to the 9th. Now I can take care of the fraction bar. Since these are like bases, but they are divided, I will subtract. And so 14 minus 9 is 5. My biggest amount is in the numerator, so my remainder will be in the numerator. And finally, 29. Now, this one, the only thing you may want to see is maybe put you some space in here. There is your coefficient, your constants. Here is the base of m, and here is the one with base of n. You could have left them all together, but I did spread them out. And so you just simply take care of the numbers like you always do. That's 5. Now, for the base of m, it is the exponents 5 minus 4, which is 1. I will put that left over in the top because that's where my greatest exponent is. And then for the ends, I have 12 minus 7, which leaves you with 5. And those are in the numerator as well.